Hello everyone, welcome to Dr. Ravi's Academy. In this video lecture, we will be understanding how to solve a problem on resultant of coplanar non-concurrent forces. Let us look at the given problem. So here a frame is given. Replace the system of forces acting on the frame as shown in figure by a resultant force R through point A. So this is the point A. So you want to replace that system of forces, number of forces with a single force at point A, and a couple, because it's a non-concurrent forces, a couple will be, or a moment will be acting, and that moment is asking you to replace by means of a couple acting horizontally through B and C. This is B and this is C. So at these points, 2 points. So this is the given problem. So let us first of all write the equation for sum of the forces. As you know that there is no force acting along the horizontal direction. So let us take the sign convention XOY, standard reference axis XOY, and there is no force is acting along the x direction. Straight away you can write down sigma Fx is equals to 0 because there is no force component is along the x direction. Now you can write down sigma Fy, sum of the forces along the y direction. Or let us see, the frame is subjected to three forces: 20 kilonewtons, 30 kilonewtons and 60 kilonewtons. 20 kilonewtons is acting downwards, so it is minus 20, and 30 kilonewtons is acting vertically upwards, it is in the direction of y, so that is plus 30. And 60 kilonewtons is again, it is acting vertically downwards, it is in the direction of y prime, so that also becomes, it is minus 60. So this becomes, it is 50, it is minus 50 newtons. Your sigma Fy is minus 50, and because sigma Fx is 0, obviously your sigma Fy itself becomes a resultant, that is minus 50 newtons. So let us represent this force at point A. So I am representing this resultant force 50 newtons. I am not using minus sign, I have indicated by means of an arrow downwards. So the force or resultant is, this is your R. You can say it is a resultant force acting downwards at point A. Now let us write down the moment sum about point A. I am writing using a symbol that sigma MA is equals to, I am using a sign convention, clockwise moments are positive. I am using a notation, clockwise moments are positive, and let us see that the moment you select A as moment center, 30 kilonewtons is passing through this particular point, so there is no moment contributed by 30 newtons, and you have only 20 newtons and 60 newtons. So 20 newtons is contributing anti-clockwise. So that becomes, because clockwise is positive and anti-clockwise is it is minus 20, moment ohm is 1 meter, and there is no moment by 30 newtons, and you have 60 newtons that is contributing clockwise turning effect, and clockwise is positive, and that force is 60, and the moment arm is 4 meters. It is 4 meters. So this becomes minus 20 plus 240, and this is 220 Newton meters. The units are Newton meters. This is what is your sigma MA, and this he wants to replace by means of a couple acting through B and C. So you see that between B and C the distance is 2 meters, and the couple is, this is nothing but your couple he wants to replace with the couple. So your couple is C is equals to F into D, and your F is equals to C is 220 by 2, it is 110 newtons, and see that it is clockwise. So you have to incorporate a force acting at B, 110 newtons to the right, and another force acting to the left, this is again 110 newtons. So you have represented the system of forces, that is non-concurrent forces, by means of a single resultant force, that is 50 newtons acting downwards at point A, and he is asking you to replace with by means of a couple passing through B and C, because the net moment you got it is clockwise turning effect, and you have replaced with the forces in clockwise turning effect. As you know that you can represent the couple at any point as far as the moment and the turning effect remains same. I hope you understood this particular problem. Thank you for watching this video.